We're starting the part of algebra where we're going to leave some equations behind for a little bit and start working on some data analysis. A lot of this in the beginning is going to be review for you. And the example we're going to use throughout this video is a made-up data set where we went around and we asked different high school students, what is the hourly wage you're earning at your job right now? So this fake data set is right here, and it goes down, 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 down until right there. And for the purposes of what we're going to do, I'm also going to put that data set in order. So now here's the lowest rate. Someone's making $8 an hour. And look at this lucky person, $24 an hour. So we're going to take this data set and we're going to review some vocabulary terms, and then we're going to turn it into two pretty pictures. Let's begin with a review of some of the vocabulary. You won't be able to see the whole list as I'm going over this, but we're going to later on show you how you can get these values that I'm going to come up with using Desmos. So out of this list, you have the minimum and the maximum. The minimum is the smallest number and the maximum is the largest. So in context, the $8 an hour was the lowest wage that anybody had, and the $24 an hour was the highest wage that anyone had. Now, going from there, you would have the median, which is the middlemost data piece, meaning there's just as many data pieces above that one as there is below it. So if I was going to find the median and I wasn't going to use something like Desmos, I would cross off the top, or the smallest, the largest, the next smallest, the next largest, and I would keep going like that until I fast forwarded some of that. Then we would cross off this piece, and then this piece, and now I'm down to these last two. And so a lot of times you might cross off one from the bottom and one from the top, and there's a number remaining in between. That would be your median. In this case, we cross off the 10 and the 11. The median, if there is no number left in between there, is the number that is smack dab in between there. So that's how we get 1050. So the median is 1050, and one way to think about the median is 50% of the data pieces are greater than that, and 50% of the data pieces are less than that. The median is the middlemost data piece. Now let's think of Q1 and Q3. Q is an abbreviation for quartile 1 and quartile 3. And quartile, you'll notice, uses the root quart, or like quarter. So in other words, the quartile 1 is the 25% marker of your data set, and quartile 3 is the 75% marker of your data set. And here's what I mean by that. 25% of your data pieces are going to be smaller than quartile 1. 75% of your data pieces are going to be smaller than quartile 3. If you like to think of it as percents or percentiles, then the minimum is 0%, the maximum is 100%, the median is at the 50% spot, quartile 1 is at the 25% spot, quartile 3 is at the 75% spot. We'll find out how to get that on Desmos, but I'll show you real quick how to do it by hand. Earlier from this ordered data set, we found the median that was smack dab in the middle. So now you can think of this as a top half of the data set and then a bottom half of the data set. I say bottom half because it's the lower wages. So this is the 50% marker right there. So if I wanted to find Q1, the first quartile, I would start marking off smallest, largest, smallest, largest, smallest, largest, and I would keep going. And the data piece that's right between 9 and 9 is 9. I'm going to do the same thing over here. Largest, smallest, largest, smallest, largest, smallest, largest, smallest. And then I would go largest, smallest. The data piece that's right between there is 1350. So this is Q1, this is Q3, this is the median. 50% of the people earn less than 1050, 75% of the people earn less than 1350, and 25% of the people earn less than $9. These five numbers are sometimes referred to as the 5-number summary because they summarize that data set. And there's numbers outside of this 5-number summary that we also care about. For example, the mean or the average, which is just add them up and divide by how many you had. $11.60 is the average wage. Mode is the most frequent. So on that data set, the number that showed up the most is $9 an hour. And then let's look at the range and the interquartile range. The range is the distance from the smallest to the largest. So there's a range of $16 between the smallest wage and the largest wage. And the interquartile range is the distance between the first quartile and the third quartile. So there's a $4.50 difference between quartile 1 and quartile 3. The next thing we're going to do is we're going to take a look at how can we take this data set or this 5-number summary, which summarizes this data set, and create a couple of pretty pictures out of these. These pretty pictures are called data displays, and we'll do a box plot and we'll do a line plot. The line plot is really simple. You just make a number line, make sure it goes as low as you need. Nobody's making $7 an hour or lower. As high as you need. The highest wage is $24, the maximum, so going up to 25 is fine. And for each one of these data pieces, just put down a dot. So this person made $8 an hour, I'd put a dot there where the 8 is. This person made $12 an hour, so that's where the 12 would be, I'd put a dot there. As you go through that whole thing, now you have a pretty good picture of what the data looks like. It seems like most people are making $8, $9, or $10 an hour. A few people are making up here, and this person over here making $24 an hour. That's a genuine outlier, meaning it's an extreme data piece. Doing the line plot, and sometimes these are called dot plots, it just gives you a picture of what the data distribution looks like. Now let's take a look at a box plot, and for a box plot we're going to need this information, and the box plot looks like this. Sometimes called the box and whisker plot because you have a box and then 2 little kitty cat whiskers. Well, here's what's happening. The box plot is dividing in picture form your data into 25% buckets. Think of this as the lowest 25%, then the next 25%, and then eventually the greatest 25%. So what does that mean? Well, if you understand how to make this, that might make a little bit more sense to you. The 5-number summary, the minimum wage is $8. So I would find where $8 is on this scale, and I would put down a dot. The maximum is $24, so I'd put down a dot at $24. The median is $10.50, so I kind of have to do a little bit of estimating, but there's my median. I put down a dot, and the same thing with the 2 quartiles. This is about $9. And over here is about $13.50. So every one of these 5 important numbers becomes a dot. And then what I do is I take and I draw a box from the first quartile to the third quartile. And then in the middle of that box, roughly speaking, I'll put a slash where the median is, and I will draw a whisker out to the extreme ends. And now it's a picture form showing you that if you think about it this way, quartile 1 we learned was the marker that said 25% of the data is below that. That's why if this is quartile 1 and this is the lowest data piece, I know 25% of the wages fall in here. Quarter 3 or quartile 3 is right here. That says 75% of the people make less money than that spot. So in other words, 25% of the people must make more. So 25% of the data pieces fall somewhere in this range. And then this is also a 25% bucket, and this is a 25% bucket, meaning about 25% of the people make between $10.50 and $13.50 an hour. There's one last thing to cover here, and that's mean versus median. Mean is the average, and most people are used to using that. Median is the middlemost number that we find by slashing off the top and the bottom. Well, I have a new data set here, and it's kind of an abbreviated version. Pretend that this is the wages of different jobs for high school students. We still have that 24. Well, in this data set, I would find the mean and the median, and they're kind of a decent amount apart, $1.60 apart. Well, this outlier 24 is an extreme data piece, so let's pretend that that person shouldn't really be included in this data set. You know, maybe it's their grandpa paying them $24 an hour. What a nice guy. So now I take this new data set without the 24, and I notice that when I recalculate, taking out that big 24, the median has barely changed. It went from $10 an hour to $9.50 an hour. But the mean has dropped by over $2 an hour from 11.6 to 9.5. So the lesson to learn from that is this. When you have extreme values, like the 24 is an extreme value, it is going to affect the mean much more than it's going to affect the median. And you can tell that by taking out the 24, the median barely budged, but the mean changed by over $2. So the mean is not resistant to outliers, or it's easily influenced by extreme values.